Is mutually exclusive, then there's no intersection. Then this works out to be 0. Next part says now, find the probability of X union Y. The probability of X union Y will just be equal to the probability of X plus the probability of Y, since they're mutually exclusive. So all we need to do is add up 1 over 3 plus 1 over 6. That's going to be the probability of X union Y. 1 over 3 plus 1 over 6. 1 over 3 plus 1 over 6. That works out to be, I have to use my calculator. 1 over 3 plus 1 over 6 is a half. Nice. That's a half. Then we need the probability of Y intersect X complement. To find the probability of Y intersect X complement, that is going to be equal to probability of Y intersect X complement is equal to Y intersect X complement. Well, there are many formulas to use for this one, but I'm just going to stick with the basic one to tell us that the probability of Y, probability of Y is equal to the probability of Y intersect X, which we know is 0, Y intersect X plus the probability of Y intersect X complement. That's what we get. But then now, what do we know? The probability of Y intersect X is 0. And the probability of Y is 1 over 6. And so that means the probability of Y intersect X complement is 1 over 6. Probability of Y intersect X complement is 1 over 6. And that is the answer. Nice and easy. So, answer is 1 over 6. Nice. All right. Events C and D are independent events such that the probability of C is 1 over 9 and the probability of C intersect D is 1 over 24. Find the probability of, this should have been D. Find the probability of D, because probability of C is already given. Well, first thing, to find the probability of D, we know that the probability of D is equal to, well, let me not start with right there. It's better to start with what we know. We know the probability of C intersect D, since they're independent, is equal to the probability of C times the probability of D. That's what we know, since they're independent. This is what happens when two events are independent. But the probability of C intersect D is 1 over 24. So this part we know that is 1 over 24, and we know that this is equal to the probability of C, which is 1 over 9, times the probability of D, times the probability of D. So all we need to do now is multiply through by 9. If we times both sides by 9, we get the probability of D end up equal to 9 over 24. 9 over 24. That will be the probability of D. Easy, soft. That will be part A. Next part says find the probability of C union D. Find the probability of C union D. So to find the probability of C union D, probability of C union D. So to find the probability of C union D, it is going to be equal to the probability of C plus the probability of D, probability of C plus the probability of D, minus their intersection, minus the probability of C intersect D. That's what we do know. Now the probability of C, we know the probability of C already. probability of C is 1 over 9. It's going to be 1 over 9 plus the probability of D. Probability of D is 9 over 24 minus their intersection, which is minus 1 over 24. So you can go ahead and put all of this in your calculator. That will give you your answer. 1 over 9 plus 9 over 24 minus 1 over 24. You get 4 over 9. It's the probability of C union D, 4 over 9. That's it. 4 over 9. Easy. Soft. Question 9. Question 9 says events A and B are such that the probability of A is 0.6, the probability of A union B is 0.8, probability of A intersect B is 0.3. Find the probability of B. Well, we already know that the probability of A union B, we know that is equal to the probability of A plus the probability of B minus the probability of A intersect B. This is what we do know, but we know that the probability of A union B is 0.8. That's equal to the probability of A, which is 0.6, plus the probability of B, which we don't know, minus the intersection, which is 0.3. So all we have to do is bring over everything to the other side. So that means the probability of B is going to be equal to, bring over this 0.6 to get 0.8 minus 0.6 plus 0.3. That will work out to be 0.8 minus 0.6 plus 0.3, which is 0.5 as a probability of B, 0.5. Nice. The next one wants the probability of B complement intersect A. Now to find that, we can start out. I'm going to rewrite it another way. I don't like to see it like this. I like to see it this way. I like to see it as the probability of A intersect B complement. And you might say it's the same thing. Yes, but I prefer to write it this way so I can stick to my one formula that I know. I know that the probability of A is equal to the probability of A intersect B plus the probability of A intersect B complement. I love my one formula. Now the probability of A is 0.6 equal to the probability of A intersect B, which is 0.3, plus what we don't know, which is the probability of A intersect B complement. So transposing for that, we're going to get that the probability of A intersect B complement is equal to 0.6 minus 0.3, which is 0.3. Nice. Then we need the probability of A complement intersect B complement. First thing we need to know is that the probability of A complement intersect B complement, this stems from De Morgan's law, and De Morgan's law tells us that this is equal to the probability of A union B, and we need the complement of all of this, the probability of A union B complement. A union B complement. This is what we're finding. Now the probability of A union B complement is equal to 1 minus the probability of A union B. 1 minus the probability of A union B. What is A union B? 0.8. So it's going to be 1 minus 0.8. Then that will be the probability of A complement B complement, which is 0.2. 0.2. All right, so this last one is 0.2. easy, soft, capital.